Hey guys, welcome back to AlgoYogi. We are doing tree series right now and we are kind of almost done. So let's move on to our next problem, which is construct binary tree from preorder and in-order traversal. Earlier we have done a similar problem, which is creating a binary tree from post order and in order. So in order is something that's common in both the problems. You can solve that one. That's already there on our AlgoYogi page, but you can check that out on LeetCode as well. At the end of the day, we are solving them on LeetCode. They're not our problem, they're LeetCode's problem. Or maybe let's say they have taken it from other companies that have asked these problems to interviewers. But anyway, now the problem is given two integer arrays, preorder and inorder, where preorder is the preorder traversal, inorder is the inorder traversal. That's self-explanatory. Didn't have to mention that. I construct and return the binary tree. So this is what we need to return, and we are given these two arrays as input. So earlier we have done the similar problem where we created a tree and returned the root from in order and post order. We are going to take the same approach. We're going to take the same approach to solve this problem as well, and that is in preorder traversal, we traverse the roots basically from root left and right, and that means that every root was processed right in the beginning. That means what? The main root of the problem was basically has to be in the front of my preorder array. So what I would do is basically maintain two pointers, and that would be left and right pointer to basically track if I have processed all the nodes. So at the end of the day, we need to make all of these values nodes, and we have to append those nodes basically as left or right child to their parent node, and then we need to return the parent node to either, like, if that's going to have another parent, or that's going to be our main root. So we know in preorder the first element is going to be our main root of our binary tree that we need to return. So now let's say I am going to pop this value out and I make that my root. Now I have to figure out that what will be my left and right subtree. Now left and right subtree will also be created using preorder and inorder array. So but however, like now I have used three, but tell me, in inorder traversal we know we process the left subtree first and right subtree after that. So if I look for this node in my inorder, that means what? That everything before this has to be on left subtree, and everything after this has to be on right subtree. Now here we will be passing this preorder to both of these sides, and these two, basically this side will take 9 and this side will be basically 15, 20 and 7 as in order. Preorder will be common, because preorder, at the end of the day, we are just iterating preorder just to get the root node, and we are using that value to find out how many values will be in the left subtree of that root and how many values will be in the right subtree of that root. So this problem is going to be like now quite simple now, because I've already told you the process that we're going to do. We're basically one by one we're gonna pop out the values from my pre-order. So I pop out 3 and then I pop out 9, and the reason I'm moving like because I'm moving from in pre-order from left to right, and we know it's the root that we are processing, and I know because pre-order was root, left and right, that means what? So I process the root, then I process left. So that's why in order, when I'm placing left child and right child onto my root, I'll process left first and then I'll process right, since we follow root, left and right order in my pre-order traversal. Now since I have to, every time I have to look for this index of my root in order, so I will create a dictionary which will take a big of n space, but that will give me constant time complexity to basically look up the values and basically create decide what will be my pointer when I'm actually just passing in left and right pointer in terms of how much of the values I will be passing to left subtree and right subtree depending on where my root is located. So next time in the left I will find 9, and 9 doesn't have anything to left or right, so that's why just 9 would be the left subtree. And then in my right subtree, basically when I move forward, 20 will be my next root, so this place will be taken by this 20 over here, that will be my next root. But then these values and these values, sorry, 20, not 7 and 15, they will go to left and right. I think now we got the idea how we're going to solve. So let's write the solution, and I think when you are solving such kind of problems, I would say like try them first and imagine in your head how the logic is working. It's not like really if somebody is explaining them on iPad, clearly they're also gonna stick around in your head. It's not like that. I think you gotta sit down and just imagine where are these values are basically you're placing them, how you're finding it in an array, how you're basically dividing like left and right subtrees values, and then why is it like pre-order, why I'm like pulling out these values, and why are they like the nodes like roots of my tree that I'm going to return. So as I said, like I'm going to have in order dictionary so that I can look up the values in constant time from in order array. So in order, I'm gonna call them index just so that it just matches the name. So for I comma node, or I could just have said it value because it's not node right now, so I'll just call it value because it's a value of in order that we will later be converting to nodes. Okay, so in enumerate, and that is in order. All right, so our index is ready. Now I'm going to have a simple DFS that's going to take left and right pointer. Initially this will be passed as the length as like 0, and the last element, the last length, which be length of in order or pre-order, they're both same, and -1. But now if ever my left become greater than right, that means I have processed all the values, and then I will return none. I will also maintain, I don't want to like pop from the front of pre-order because that will again take like popping from the back of the array takes constant time because you don't care like what you're doing later in the memory. But I think it's like clearly visible. If you're popping from the front, then all the elements needs to be shifted to the front of to occupy that void you left while popping. So that will take constant amount, like big of n time complexity, and we don't want that. So I'm going to maintain let's call it pre-index, and I'm gonna use array so that I can reference it inside my inner function. So what I'm going to do is I'm going to pop out the root, and root would be just preorder. Okay, let me just have tree node, and it will be preorder, and that will be pre-index. So pre-index, and what I'll do, so I'm not accessing it like just pre-index, but like that. And let me increase also pre-index, because next time I'll be popping the next root that will go to the left or right, depending on if they exist or not. So that will be +1. Alright, so now let's place root.left and root.right, and that is just simply calling DFS recursively on left and right pointer, and I'll just change these left and right pointer. I'll show you how I'm going to change it. So now for left subtree, left will remain left, but right will be my in order index, and here will be the value of root.val. So initially, if I'm looking for 3, then I would find it on the second index in the first example, if you remember. And then I'm going to I already processed the middle value, which is root, so I don't want to process that. So I'll just move one value back, and then same way I will be basically changing for right side. I'll be just increasing the left pointer just next to the root, one more to the root. I'll add one more to the root. Now what I'll do is just simply return root, and then I can just return DFS on 0, and we can pass in pre-order or in order length. Both are same, so it doesn't really matter. Let me pass in order because it's my favorite. Well, this seems clear to me. Let me try to zoom out and run, and this is okay. Yes, because we are dealing with the values, and we don't want to pass in length of in order, and because that wouldn't exist over there if I'm passing this one. If I'm passing this one, that means like I will have to get one more. I will be running my right one more time for R, and it will remain like lesser. So let's run that. Alright, let's submit our answer, and yes, alright, passes beats fair amount percentage of solutions there. Alright, let's write down the time complexity. You already know that is like we're processing all the nodes in our arrays, and we're doing DFS search, so we're only going to each node once. Alright, okay, and then what we do is space complexity is, I already told you guys, space complexity is big of n, since we are storing all the values in our dictionary. Although in not implicit, it's like, yes, I think implicit, maybe, I don't know, it's like although it's not visible that this DFS function is also using memory, but in the background when it's running, like these iterations, when we're calling DFS, and until it reaches the height of the tree, it will keep calling these functions, and in the end it just returns the root. So at maximum it would be the height of the tree, if we didn't have this particular memory consumption. All right, okay, let's go back to our AlgoYogi and mark this problem solved. All right, so I'll see you guys in the next problem. Until then, bye-bye.